Assalamu alaikum my students. Today we are going to discuss solve the word problems using scientific notation and with correct number of significant figures. But we must know first what is scientific notation and why we will use it. So basically to represent a very small number or to represent a very big number we use scientific notation. So just like we do have the very smaller number, that is 0.0000, another 0 and 56 kilogram. We want to represent it, so we need to represent by using the scientific notation. And standard scientific notation, we have to write the decimal just after the non-zero digit from the extreme left, just like 5.6 into 10 power minus 6 kilogram we are going to represent right here, because whenever we do move the decimal from left to right we have to write within the negative number. To represent very large number, just like speed of light in vacuum, 3 after the 3 we do have 8 times 0 meter per second in vacuum, so we can represent it with the scientific notation as 3 into 10 power plus 8 meter per second. Means we are shifting the decimal from right to left, so we have to represent it with the plus, and the 10 power will be represented as the number of decimal places we have moved from the left to right, from the right to left, sorry. Then take another example, just like 2,30,000, so we can just write it 2.3 into 10 power 5, and 0.00078, so we can write it as 7.8 into 10 power minus 4, because we are moving left to right. In the same way, the next situation we do have, after 45 there is 1 2 3 4 5 times 0, so we can represent it as 4.5 into 10 power 6. Again, it is more than one situation and we are moving the decimal from right to left. Now again, we do have a smaller number, just like 0.0000078, so we can write it as 7.8 into 10 power minus 6. Now we are going to discuss about significant figure. The number of reliable digit in a figure is called significant figures. There are rules to determine the significant figure. The first one, all the non-zero digits are all significant or reliable. Just like 33.2 has 3 significant figures. Rule number 2 says that zeros between the non-zero digits are all significant. Just like 2051 having 1 2 3 4 4 significant figures. And in the same way, if 0 lies between the two non-zero digits, so they are being significant or reliable. Leading zeros are not significant, just like we do have 0.54, so this 0 is leading 0, means for the less than 1, the zeros we do have in the beginning, they are not reliable or not significant. Just like 0.54 having 2 significant figures, 5 and 4, while if you do talk about the leading zeros in 0.0032, these all 3 zeros are not significant, so only 2 significant figures we do have. Trailing zeros to the right of the decimal place are significant. It means that 2.000 having 4 significant figures, 12.00 having 4 significant figures, means trailing zeros or the final zeros just after the decimal are countable or significant or reliable. Another example, if you have 3.000, it is having 4 significant figures. All the trailing zeros after the decimal, they are countable. Now the next rule, in the case of scientific notation, just you have to look at the number which is other than 10 and its power. Just locate the number of significant figures in number that is given other than 10 and its power, just like n into 10 power x written in the scientific notation. So just you have to locate in the case of n only, no need to locate in the 10 power x. So just like 5.02 into 10 power 4, so we have only 3 significant figures and we don't need to see this 10 and its power. Now try to find out the number of significant figures in the following questions. 2.35 have 3 significant figures, all the units are reliable. If we talk about 0.00045, it is having only 2 significant figures due to the trailing zeros are not significant. Now 1.005 have 4 significant figures because zeros lie between the non-zero digits are significant. In the case of 4.5, triple zero, so we do have final zeros are countable after the decimal, so it is having 5 significant figures. 3.7 into 10 power 34 having 2 significant figures. Now significant figures in the mathematical operations, just like plus, minus, multiply and divide. So what we have to do right here, first we have to round off the answer to the least number of significant figures, and the question arises how we have to round off. So if the last digit is more than 5, we will simply drop that last digit and add 1 to the retained digit. And if the last digit is if the last digit is less than 5, so simply drop that digit, and no effect in the retained digit. And if you do have the last digit exactly 5, then it depends on the retained digit. If it is odd number, you have to add 1, and if it is even number, then it remains same, and the last digit will be dropped simply. Now we are going to understand this thing by a question. Like here, this what problem we do have: find the area of the rectangular slab having the length and the width as 2.31 and 3.2 centimeters with appropriate significant figures. So what we will do, we all know that area of slab, that is length into width, and 2.31 multiplied by 3.2, we do have 7.392. But this will be but this is not the correct answer. We have to round it off to the least number of significant figures. You can see that 2.31 and 3.2, in the case of 3.2 you do have 2 significant figures, and 2.31 we do have 3 significant figures, so least one is 3.2. so final answer we have to round it off to the least, means least means 2 number of significant figures. So final answer will be 7.4 instead of writing 7.392, because we have rounded off to 2 significant figures. Now find the answer with the appropriate significant figure. There is algebraic operation indicated right here: 2.72 multiplied by 3.1 over 7.82. so if we do directly does it, so we do get the answer 1.0762. but according to appropriate significant figures, what we have to do, we have to find out the least number of significant figures. 2.72 having 3 significant figures, 7.82 having 3 significant figures, 3.1 having 2 significant figures only. So what you have to do, we have to write it in 2 significant figures due to the least one, that is 3.1. so we have to write the final answer into 2 significant figures. So we do round it off. So 2, if the last digit is 2, so it is less than 5, so simply drop it. 8, so simply drop it and add 1 to 7, so it becomes 1.08. but we have to round it off to 2 significant figures, so 8 will be dropped, so that is more than 5, so we have to add 1 to the 0, so it becomes 1.1 will be the final answer. Thank you.